Internally, externally, that should be what data type. Why data type means data type. Correct. So when you are connecting this into your design module, this is nothing but your external environment. Correct. How you are connecting the input or connecting as what? Reg net data type. You are connecting this as a reg data type. Correct. Then how outputs are connecting as y data type. Means data type. S comma C0. Do you understand? This is what definition I was talking about here. Internally inputs are net data type. Outputs are reg or net data type. In out are net data type. So when it is connecting to the external, these are inputs are what? It will be reg or net data type. Outputs are net data type. Now in output are net data type. You understand why we are representing in a module, in a test bench, why you are connecting inputs and data type. These are the port connection rules. You do understand? This is the inputs are declaring as what? Regs. Or you can use the virals based upon what model you are doing. So this is declaring as a what? This is output declaring as a y data. But internally when it is coming to the internally, inputs are y data type, outputs are reg data type or y data type, reg or y data type. When it is reg data type, output it is capable of retain the value or store the value. Did you understand why we connecting inputs are reg in the test benches, outputs are connecting in the y in the test bench. So this is nothing but a port connection. You should know when you are designing, when you are writing that your ports are connecting to the external environment, how you should connect into the environment. Did you understand this? This is the what? Input, output, in output, internally what it is connected and externally what it is connected. Input ports, output ports and the in output ports. So these are the port connections, port connection rules. Is it always necessary that I should match the, suppose I am using full adder, this is my full adder, this is my design file, this is my test bench. Is it always I should match in the ports or I can do the unmatching of the ports? Is it matching is mandatory or I can go with dropping the ports? Matching is mandatory. What will happen if I am dropping any ports? Suppose I want to debug. If you see full adder, there are two outputs, sum and the carry. I am going to drop the cout. Why? Because I want to see debugging of the sum value. So that Verilog have a flexibility of width matching and unconnected ports. Means it is legal to connect the internal to external items of different size when making internal module port connection. However, a warning is typically issued that the width do not match. Means the width of the port matches. If it is we are using width of 3 down to 0 in the design file, but in test bench you are writing 7 down to 0. Legally it is correct, but what will happen? It is legal to connect the internal and external items of what? Different size. In design file your design depth is 3 down to 0. In test bench you are writing 7 down to 0. It is legally correct. But what basically this compiler will do is nothing but it will throw internal module port connections and it will give me the warning. But internally it is connected. It will be connected with the different size. But it will give the what? Warning message. Means, however, a warning is typically issued that the width do not matches. So this is nothing but a width matching concept in the port connection. So another one is nothing but unconnected ports. Unconnected ports. So Verilog allows ports to remain unconnected. That means, if you take an example, certain output ports might be simply for debugging, and you might not be interested in connecting them to the external signal. So this we call it as what? Unconnected ports. So you can let a port remain unconnected by instantiating a module as shown below. You can see in this example, this is a full order. I'm instantiating what? My module in the design file. Now I'm doing what? Unconnected ports. Means I'm dropping what? I'm dropping the CO. So by leaving this as a what? Space separated by the comma. So what is the use of this is? What is the use of this is? Verilog will be allowing what? To do the unconnected ports. So what is the use of this is nothing but certain output ports might be simply dropped. For what purpose? Debugging. So that is the meaning of unconnected ports. So when you are doing the connection of the ports, one, the width is not matching, but Verilog will legally accept. But it will throw the what? Warning error saying that width is not matching. One thing. And second thing is allowing for what? Dropping the ports. Correct? How you can drop the ports is, now you can see I am declaring this is A, B, C, C and S and P naught. When I am instantiating this in my design file, test bench, how I can do? A comma, B comma, C, I am doing port by order list. Port by order list. Now I am going to drop what I am going to drop here. C I am dropping. C out means CO is dropping here. So I am dropping this CO so that I can only debugging the what out somehow. This is the one, means this is unconnected ports. So first one is nothing but matching, port matching. Port matching means suppose you declare this as 3 down to 0. 3 down to 0, A comma B comma C. Let us declare this as input CI. Now in the test bench, suppose you are connecting like A comma B comma C. This is also reg CI. What happens here? What is my AB here? Width of port. What is this width is? 8. So size unmatches here. It is legally it is accepting, but it will throw the error that this will be the 4-bit width and this will be what? 8-bit width. So this is about this width matching concept in the port connection when you are connecting the ports. So it is legal to connect the internal and external items of different size when making internal module port connection. So however, the warning is typically issued that the width do not matches. If you are using different width, means unsized width, it will accepting, but it will throw the warning error. And then you can drop the one. You can also do unconnected ports. What is the use of this unconnected ports means? For debugging. If there are 10 outputs are there, you can take, if my any hardware modeling will having 10 output ports. So when I am instantiating my design file, I want to debug the first output port. Then in that case, what I can do? I am going to unconnect the remaining 9 ports. How you can unconnected means by leaving the space comma. If there are 9 ports you are unconnected, then you can do like this. Did you understand? So this is nothing but an unconnected ports. What is the use of this is unconnected ports? To debug the outputs. So to easy debugging of the outputs, you can do what? Unconnected ports. Are you clear this? So this is one example. We are dropping the what? C out. So other port connection rules are, so this is what, let us see, this is an example of legal port connection. So this is my top module, means test bench. So this is reg A, 3 down to 0 A comma B, reg C. So in design file inputs are declaring as a by data type. In external module, in the top module. External module means what? Your top module. Is it clear? If you look at this one, if I draw the one more square box here, that the biggest square box is your top module or external module. What is your internal module is nothing but design file. Correct. So this is an example for top. The top module inputs are declaring as a reg. Correct. Again, scene also declaring as a reg. Then sum is declaring as a reg. This is regarding, this is nothing but 4-bit parallel adder. Sum is declaring as a reg and Cout is declaring as one output is declaring as a void adder. So when you are instantiating the full adder, you are calling it a full adder, correct? Full adder, this is a module name, a design module name. This is a duty. Duty name you are writing what? Full adder 0. Now sum Cout A comma B comma C. So this is illegal connection because output port sum is in the module 4 is connecting to the what? Register of the sum in the module of the top. Is it legal? This is legal way to connecting here? No, right? Because here in this case sum is should be connecting into what? Void data type. Correct? Sum is connecting to the void data type. Cout is connecting into the void data type. So that this is an illegal connection because output port sum is module 4 is connecting into what? Register variable sum in the module now. So this is a one example for illegal port connection. So this is problem is rectified if the variable sum is declared as a what data type? Native data type. How you can rectify this problem? Declaring the sum as what? Void data type. Void data type. A similar problem would occur if an input port were declared as a reg in the design under the test. So this is an example for what? Illegal port connections. Are you understand this? Now, when you talk about this port connection, when you are connecting the internal module ports are connecting into the external module. Your internal module is nothing but what? Your design file. External module is nothing but what? Test bench. That is your top module. Top module. So there are actually 3 methods are there. There are 3 methods to connecting the what? The ports from internal module to the external module when you are instantiating. There are 2 methods of making the connection between the signals specified in the module instantiation, where you are specifying that internal ports connection and the external port connection is nothing but during what? During instantiation of the module. The ports in the module definition can be 2 types. The 2 methods can be mixed. Okay, one is connection by order list and another one is what? Connection by name. So we already spoke about this. What do you mean by connection by order list? And what is connection by name? So connection by order list means what? The way we are declaring the ports in the module in similar fashion in your module instantiation in the test bench also you should do the port connection in the same fashion. Correct. Module port connection by name defines what? Using the dot formal port, then in the bracket, inside the bracket you are writing what? You are writing actual port. Correct. So if I am talking about, I can take this as A comma B also right here. This is A comma B. When I am talking about port connection, this is my module name. This is the design under test. Then how I can do the port connection here? 3 ways you can do. One, B comma yes, is nothing but order list. This is nothing but order list. Port connection by order list. And what is mean port connection by name is DUT. Right. Now you are writing like this. So what is meaning of this is nothing but dot followed by what? Formal formal underscore port, and then inside is what you are going to actual. This is nothing but actual underscore. Did you understand this? How you can write this formal and actual ports? Dot. Shall I use the capital leaf?
Yeah.
So here comes what port it is. Test bench port or design port? Test bench port. Now I can write like this. Capital A, small e, comma, dot. This is my formal port. Of what? Actual port is what? E. Again next. Dot. Capital CI, C, then dot. S of small s, comma, dot. CO of CO. This is fine? Okay, let us check this program. So this is what output. This is a full adder. Let us design for 1 bit full adder. So shall I use the assign statement? Assign statement. How to do the full adder? So let us go with the operators. With the concatenation operator, I am going to do C0, comma, yes. I can write A plus B plus C, correct? Or other way I can do is nothing but S is equal to 1. A XR, B XR, C. This is nothing but bitwise operator, right? CI, and then assign CO is equal to A and B, correct? R operation, E and B and CI, correct? R operation, AC, A and CI. Shall I write like this? So I am using the parenthesis. So the way it is doing the operator order precedence. To avoid that precedence, I am using the parenthesis. Correct. Now what I need to do? End module. End module. Now let us write the design file. So in design file, inputs are declared as what? Reg data. Outputs are declaring as Y data. So here I am doing here. I am doing the module instantiation. By port connection by name or port connection by order list it is. This is by name. Now what I need to do? Let us comment this line. I should start with what? Initial begin to generate the input and apply the input. So initial begin, then I have to generate the inputs, correct? So shall I generate the input like this? A comma B comma CI concatenation operator I am using. Row brackets. So shall I randomly generate the input? Correct? Then what I need to do? Display dollar symbol display of what? Shall I print only sum and? Okay, let us print all. A is equal to dollar symbol 0B, correct? Tab space B is equal to dollar symbol 0B, tab space CA is equal to dollar symbol 0B, tab space sum is equal to 0B, then tab space CO is equal to dollar symbol 0B. What argument I need to pass? A comma B comma CA comma S comma C. Then I should end the module, end the initial begin, then end the module. Now what connection I am doing is nothing but here port connection by name. So this is what? Dot A is nothing but my formal port. This is nothing but my actual. Now let us compile this program. So what it is showing that here, it is showing that capital A is not a port of this design under test. This design under test. So that what formal ports I can use? Small a, correct? So I should use this is small a, correct? Small b, again small ci. This is nothing but yes. This is nothing but c. So is it now I am getting the output for this program? Port connection by name. So I am getting at time t0 it is start executing, so that this is taking as both are xx. So what I need to do, let us give some time, simulation time to produce a summon cap. Now you can see A is 1, B is 0, Ci is 0, so S is equal to 1 and Co is equal to 0. So this is the connection, port connection by name. Again, this is nothing but port connection by order list. And then what is the other one is port connection by default. Port connection by default. So this is a port connection by default. So what I need to do? Start with the dot star. Means it is selecting all. So how this dot star will work is nothing but this dot star works like similar to your what? Port connection by name. So A is connecting into the B based upon number of ports. B is connecting into the B. C is connecting into CA, so on. So this also works. Okay. So this gives me the same result. So what is the meaning by this is nothing but port connection to the external signal is 3 types you can do. So one is nothing but what? Connecting by order list. Connecting the ports by name. By name. Now see, what is mean by this connecting by order list is? How we have done the connection by order list is? Connection by order list is a most intuitive method for beginners. Okay, so the way you are declaring here, full order A, B, C, A, S, CO, in the module instantiation also, you are doing the same connection. If you are connecting here CO, here some other port name, the compiler will compile the program without throwing any error. But you won't get the what? What predictable you are expecting. Correct. This port will be connected, but it will not get the predictable output. So this is the most intuitive way where the beginners can use what? Order list. Imagine if there are 100 ports are there. So connection of this port list is a limitation then. Correct? So the signal is to be connected must appear in the module instantiation in the same order as the ports in the port list in the module definition. How this connection by order list will work? The signal to be connected must appear in the module instantiation in the same order as the ports in the what? Port list in the module. Means the way you are writing this should follow. This is my port connection by order list. This order should follow this, right? This order should follow this. If you are not following, compiler will compile, but you won't get the predictable output. That is a definition here. So notice that in module full order, if you take a module full order, the external signal sum C out A, B, C appears in exactly the same order as a port sum C out A, B, C in the module definition of the full order. Let us take this example only. 1 bit full order. So we are connecting the ports as we declaring the order of the ports in my module. Did you understand? So this is the definition of the order list. So what is the limitation of this order list is? So before going to the limitation, you can see this is an example for what? Order list. This is my top module, test bench. So this is my input. This is the program for 4-bit parallel order. So A and B are 4 bits. Inputs are declaring as a reg. Outputs are declaring as what? Wide data type. So our signals are connected the ports in the order by position. You can also another name to this is nothing but port connection by position also. Port connection by order list and port connection by position. So this is my design file. Then you tell me how you can connect the according to this the port list. How you are connecting the port connection by position. Sum is connecting into the sum. COT is connecting into the COT. A is connecting into the A. B is connecting into the B. And C is connecting into the C. So I said that this port's name, input and output names, in the top module, this will be declaring, you can use the capital letters. Or you can use the small letters. To differentiate that this is my design file and this is my test bench. This AB are declaring this as what? Capital A comma B. Okay, let us run this program. Now here I am going to write. I am going to declare in the inputs are what? AB. Here this is nothing but I am going to write CA. This I am going to write sum and this is nothing but CO. C0. So how I can do the port connection? By position is ABCA is there. So that I can write here what? Capital A, capital B, this is what? Capital CI, this is S and this is C0. And what I need to change here? This should be capital A, this should be capital B, this should be what? CA. Here I need to argument I need to change. What argument I need to pass? Capital A, capital B, capital C, capital S, capital C. You can understand. Now it will gives me the same output. It is always not necessarily that what are the ports you are using for the design file. Port name, input and output port need not be the same. You can use the different name. But earlier what I am trying to do is when I am doing the port by connection, these formal arguments I am using as what? Capital letter. Now if I run this, is it I am getting the output for this now? I am doing the port by connection name now. Is I am going to get the output? Now here my formal port is nothing but what? Capital A. My actual port is what? Small a. Small a piece. Now what I need to do here? I need to change my, correct? All the formal ports to what? Capital case. Now this is connecting into what? B. This connecting into what? This connecting into the S. And this is connecting into the C. Now did you understand? Now I am getting the output for this. Let us change. This is A. This is B. This is CI. And this is capital S. And this is C. Now I am getting the output for this. I am doing what? Port connection by. Let us check this program. I'm using ABCI port connection. So line number 21. Okay, the small changes is nothing but I have to connect this formal port. This is the actual port. Okay. This is B. So this is small b. This is capital B. This is small c. This is capital C. This is S. This is capital S. This is small c0. And this is nothing but capital C0. Let us run this program. Did you understand this? So the port connection by name. Now this small a is nothing but now for me what port it is. Formal port. This formal port is nothing but what? My design file. So this capital A is nothing but what? My actual port of what? My test. So sorry, I was done reverse earlier. Correct. Now the correct way to do the port connection by name is these are your actual ports of your design file. And these are nothing but what? Formal ports. These formal ports are used in where? Design. Did you understand now? So usually a test bench variables are declaring as what? Capital cases to differentiate the design file and the test bench file. Or if you are using this is small a, small b or some other letter, x comma y also it is fine. I can declare this as what? X comma y. Correct inputs, and this I can declare as z, and this I can declare as m comma n. This is also fine. How I need to connect here? How I need to connect? This is connecting into x, correct? This is connecting into y, and this is connecting into z, and this is connecting into m, and this is connecting into n. Then here what I need to do? What are the inputs for me is only x comma y comma z. In the display, I should make this is what? X, this is y, this is z, and this is n now, and this is n. N what argument I need to pass now? Now I need to pass x comma y comma z comma m comma n. Now this is also works fine. Are you understanding? Now if I'm using this order list, what is my port connection, sir? Here, or connection by port connection by position. Then I can write here it is nothing but one x comma y comma z comma m comma. So this is my port connection by order list. So I hope now you're understanding what is by port connection by order list, port connection by name. So this is one example. So this is an example for what? Port connection by order. Now let us see what are the limitations of this port connection by order list. Order list, okay. For larger design, where module have how many number of ports? 50 ports. So we are working with few very simple one, half order, full order. Quickly we are going with 4 outputs or 8 outputs. Think about there is a model which will be having how many ports? 50 ports or 100 ports. Remembering the order of the ports in the module definition is impractical and prone to the error. There are 50 ports are there, 50 output ports or 100 output ports are there. Remembering all and doing the port connection by position order list is became tedious or impractical. If you miss any one position, it will throw the error. More thrown to the error. If I go with what? Port connection by not name, order list. Correct. Port connection by order list. So that Verilog provides the capability to connect the X signal to the ports by what? Port by name. You refer the port by name using dot port in the bracket actual port. So rather than by what? Rather than by position. See, you can use the position also. What is the problem of the position is what? If port output ports will be having 50 ports around. That I need to do the correct position. If I miss any one position, I'm not going to get a predictable output. That is what? By module definition is impractical and more prone to the error. So Verilog have a capability to connect the external signal to the ports by port name rather than what? Port by position. So you can specify the port connection in order as the port name module definition correctly matches the external signal. Now you can see this is an example for this example for what? This example for what? Port connection by name using dot formal port parenthesis actual. Did you understand? So this will avoid this one. For exclusively connecting A is connecting into A, dot A is connecting to A, dot B is connecting into B, so that the practical implementation error prone to the error will be less by going with what? Port connection by name. Did you understand? Now this port connection by default, this is the one, right? So this is port connection, this is nothing but. This is a port connection. Port connection by what? Default. Default. How this will works? Port connection by default. So it is exclusively, this star indicates on the port list. Port list. So this is connecting exclusively. X is connecting into A itself. Y is connecting into the B itself. Z is connecting into the C. The order you use specifically the module. Did you understand? So these are the three types of the port connection. Port connection by order list, port connection by name, and port connection by default. So what is the limitation of this port connection by order list? Somebody will ask you that. See, in this stage preparing this one, port connection by name. Why? They'll ask. Because the port connection by order list is impractical if you have a 50 ports or 100 ports. Then the position, if any position I am missing, I will be on getting the predictable output. That is more prone to the error. If the port size increases, list increases. So then what I can do? I can go the port connection by name by referring the exact port names. Or this is also fine. Default, port connection by default. So this default works like exactly what? Port connection by name, but internally Verilog will take case. So these ports are connecting to the by port connecting by port names. Internally it will does the job. This star indicates here selecting all. This is like a meta character. The meta character means in the regular expression. So few meta characters we are using star, plus, dot. This star indicates that the text will appear at zero occurrence or more number of occurrence. Means star indicates here it is selecting all the port list here. Did you understand? So this is the port. This is nothing but port connection by name. You can see in this example. This is clear. So this port connection by name, those ports that are to be connected to the external signal must be specified in the port connection by name using dot with the formal port in the bracket actual port. So unconnected ports can be dropped. How you can do the unconnected ports can be dropped? Leaving the white space. Correct? So you know that ports are also unconnected. Unconnected ports can be dropped. For example, if the port Cout were to be kept unconnected, the instantiation of the full order port would be look like as how it will be look like as. This is full order dot sum. Sum is connecting to sum, comma. So you don't mention the what? That port when you are doing the port connection. By default, we are dropping the what? Port unconnected. Now this here A is connecting into the A. I can write like this also, right? If I am going with the port connection by name, let us tell you one more concept here. Let us write this at the end. Is it fine? Or I need to write the way it is order specified in my design file. This is also fine, right? We can write. Because, why? Because we are not following the order list or a position. We are referring the what? Name. By referring the name, you can you can mismatch the order. When you are doing what? Port connection by name. This is clear? And then if I want to drop a Cout, what I want to do? Simply what I can do? I'm going to drop the Cout. So this is nothing but what now? What is the example? This is nothing but unconnected port example. This is. Now by default, what is the n value I am getting it? Since it is declaring as a white data type, what is the default value of the white data type is n? N is nothing but unknown. Why I am printing n is equal to z like this? I am printing that value. That's why by default value of n is declaring as a y data type. What is the default value of the y data type is z. So it is printing n is equal to z. So now what I have done here? I have unconnected the port when I am doing the module instantiation. Did you understand? So how to do port connection by name? Yes. See, this is star. This star indicates is that selecting all this. That's it. If there are 50 ports on there, again this is typing tedious job, right? The order you can mismatch, but dotting a dot a1 dot a1, b1 dot a2 dot a2, so on. Writing is a tedious job. In that case, what you can do? You can go with what? Dot star. If connection by name only, where list is preferred, this is exactly work as a list. Connection by name. They use this one or they use this one. Both are same. Can use this one or this one. But the way this is working is different because I'm using star. It indicates that it is a meta character selecting all. I'm just telling you that this dot star is same as and what here connection by name. Here I'm exclusive writing here a formal port of actual port. Example I'm telling you connection by name. So this I can write what dot star also. If you use this also no problem. If you use this also no problem. This both are works like what connection by name only. Is it clear? If there are less ports are there, you can go with this. There are more ports are there. What you can do? Why you can go port connection by what? Default. Did you understand? So in port connection by name, the order is you can write in different way. But when it is connected to the port connection, it is connecting A is connecting into what? X only. B is connecting Y only. If you mention any order. And also you can drop the what? Port connection for the debugging. This is the definition. Here we are dropping what? COT is simply dropped from the port list. So another advantage of connecting by port name is that as long as the port name is not changed, as long as the port name is not changed, the order of port in the port list of the module can be rearranged without changing the port connection in the module instantiation. Did you understand this point? The point is port connection by name is that as long as the port name is not changed, port name is not changed, the order of the port in the port list of module can be rearranged without changing the port connection in the what? Module instantiation. That means I am not adding the port list here. Correct. I'm not adding the what? Port list. I'm going to change this. First, I'm going to do C, comma, C. Then I'm going to keep A, comma, B, comma, C. A, comma, B, comma, C. And first, I'm declaring the inputs, outputs. Names are not changing, but the order I'm changing. If I'm changing the order also, this will work fine. This is another advantage of the connection by port name. So in the previous case, I put the first inputs, then out. Now I am not changing the port names. Just the order I have. First I put the outputs, then I am putting the inputs. So in such case, if I am doing this port by order list, it will not work. Even though it will compile the output subprogram, but you want to get the predictable output. In such case, what happens? X is connecting into the sum. Correct. Y is connecting into what? That you won't get the predictable output. I am not naming the ports. The order I have changed. Even though if I am changing the order of this my internal module, if I am using port by name, it does not affect the output. Correct? So this is the second advantage. You got the point. Two advantage of going with the port by name. One advantage is what? What is the first advantage? You know, large ports are there. 50 ports or 100 ports are there. If you miss any one position, correct? You won't get a predictable output. Second, this is a disadvantage of what? Port by order list. If I am not changing the name, if I am changing the order in my internal file, internal module, that will affect the output. Correct? So what I mean to say, I am using here order list. This order list I am using. Now I am changing the order in my internal module, design file. Is that I am getting the predictable output? No. This is second disadvantage. To overcome this, what we are going? We are going with port connection by name. I don't understand. So you think that this port connection by order list will be some sort of error prone if you are not positionally not connected. So you won't get the predictable output. That is left to you. You can use order list, no problem. You can use port connection by no problem. But port connection is preferred. Port connection by name is preferred. Because of the two limitation in the port order list. Did you understand this one definition? Connection by name. So this is regarding about port connection. Port connection. Now we talk about what is by port. What are the port list? Types of the port list. Correct. Input, output, in-out. Then how to declare the inputs when it is coming to the internal module. When it is coming to the external module. External module is nothing but what? Your top module or a test bench or a stimulus. How you are connecting internal module to the external module. Correct? And then how when you are instantiating, how ports are connected. Port connection. Port connections are done using order list, are done using what? By name and then by default. Did you understand this concept? Then what is the limitation of the order list? Are you understand? Now this is regarding a port, the module definition, port list, port declaration and connection tools. Port connection tools. Is it clear this? Then let us go with other topic of Verilog is Verilog is supporting for the hierarchical naming. So hierarchical modeling are basically three types. One is top to bottom, bottom to the top, or you can go with a mixed modeling. Correct. So this is hierarchical. So here, what is mean by hierarchical naming Verilog is the top level module is called it as a root module. Because it is not instantiated anywhere, this will be the starting point. To assign a unique name to an identifier, start from the top level module and place the path along the design hierarchy to the design identifier. Let us take an example to this. So this is an example for designing the hierarchical part SR latch simulation. This is my top module. Means stimulus, root level, and then root level what I have? SR latch. This is my root level, and next is what? SR latch. And then in the SR latch, how I am designing? If you remember the NAND latch, using a primitive gates, right? N1 and N2 are the primitive gates. So using this, we are designing the SR latch. And then this is my top module. So in the here, this is my gates to designing the SR latch. In the SR latch, what are the inputs and output with signals are this? Q1, Q bar, yes and the My top module, if you look at my top module, what are the variables to the top module is? Q bar, set, reset. These are the variables. Are in the top one. So this is nothing but hierarchical name. Or you can do the hierarchical name. To assign a unique name to the identifier, start from the top level. I want to name this. Suppose I want to name the S. How I can name this? To name this, I can go with the top level module. What is top level module name is? Let us take top. Then I should mention the what? Trace the path along with the design hierarchy. Now if I want to mention yes, I need to trace this. This is my top, then dot, M1, dot, yes. So this is how you can hierarchically design to design the identifier. So let us take one example so that you will be understanding. So in the SR, same one. The graph it shows here, picture it shows, presenting in terms of texting. So here hierarchical naming means for SR lab simulation, stimulus is the one, top level module. Since top level module is not instantiated anywhere, correct? Are you instantiating your test bench anywhere? Is it test bench will be instantiated anywhere? Design file will be instantiated where? Test bench. My test bench is now what? It is a top module. This top module will not be instantiated anywhere. So if you take an SR flip flop, SR latch simulation, the stimulus is a top level module. Since the top level module is not instantiated anywhere, I can call this is nothing but what? Root module or a up module. The identifier defines in the modules are what? In these modules are what are the identifier or variables is Q bar, set and reset. The identifiers are Q bar, set and the reset. The root module instantiate what it is going to instantiating? It is going to instantiating this one. M1. What is M1 is nothing but my design module, right? My design. I'm going to instantiating where? In my top module. What is my top module is? Test bench. So I'm instantiating this. The root module instantiate. The module name is M1, which is a module type of one. What is a module type of this? SR latch. SR latch. The module M1 is instantiated what? Using what gates? NAND gates. So this SR latch is designed using what? NAND gates. SR latch. Two NAND gates are there. So this is the one. The module M1 is instantiated what? Using primitive gates. Gate level module. NAND gates N1 and N2. What is Q1, Q bar and S and R are? This is nothing but these are the port signals to what? My module M1 means my design file module M1. So hierarchically how you can referring this? Hierarchical naming referring, assigning a unique name to the each identifier. Means all these are my identifiers. Q, S and R identifiers. How you hierarchically assigning this is nothing but to assign a hierarchical names, use the module name for the root module. Root module is my test bench. And instance names for all the modules, instance below the root module. Please let us take this example. I want to referring the S value. How I can refer the S value? I input my test bench module name, stimulus. Then dot. What is followed by M1 is module name. In name means design module name. Dot S means what? It is a identifier by module M1. Did you understand? Using dot, you can hierarchically represent the identifiers. See, the example shows hierarchical name for all the identifiers in the above simulation for this example. Okay. So this example, notice that there is a dot for each level of hierarchical name from the root module to the design identifier. So first comes what? Stimulus. This is my top module, stimulus. Then if I want to represent this identifier, how I can identify this? Stimulus dot Q, stimulus dot Q bar, stimulus dot set, stimulus dot reset. Then how I can represent this identifier? Stimulus dot M1 dot Q, and similarly stimulus dot M1 dot Q bar, stimulus dot M1 dot S, stimulus dot M1 dot R. This is how you can hierarchically name it. You can say this is a hierarchical naming. Then how to represent hierarchical naming for this one, N1 and N2? Stimulus dot M1 dot N2. So N1 and N2. Did you understand this? This is nothing but hierarchical name. So each identifier in the design is uniquely specified by the hierarchical path name. This is a path name. Using what? Using dot operator. To display the level of hierarchy, how to display the level of the hierarchy? What is the format specifier you can use to displaying the hierarchical name? Top module name is nothing but percentage. Do you need any argument to pass to print this percentage? No need. No need of passing the argument. No argument for printing the what? Hierarchical name. So to display this, you can use the percentage. So this is how you can naming the hierarchical. Did you understand this? So this, if you look at this diagram, you can easily understand what is how you can do the hierarchical naming. Correct. So your top module will not be instantiated anywhere. So that this is what your root module. So in the root module, you are instantiating what? Your design file, correct? So that if I am going to refer the any identifier in this what I can do? I should start from what? Top dot instantiation of here M1 dot. If I want to identify this, how I can identify? Hierarchical top dot M1 dot yes. Top or stimulus dot M1 dot Q bar, so on. So this is the hierarchical naming of the. This is how you can do the hierarchical naming in the Verilog. Okay. So with this we will cover with module definition, ports, port connection rules, and then port directions. Then what are the port connection by naming and order list? Then how you can do hierarchical naming of the Verilog module. So now with this, using of this knowledge and then lexical convention of the Verilog programming. So we will start with now the level of abstraction. So we will start from 4 level of abstractions. We know one is switch level is lowest level, gate level, data flow, then behavioral model. So where behavioral model is higher level of abstraction comparing to the switch level. So we will be not talking about the switch level. So we will start with the data flow, then gate level. Actually, I should start with the gate level. So I have changed the plan to start with the data, because data flow most of the time we are writing using the Boolean expressions. You are already familiar with the Boolean expression, right? What is a Boolean expression? Carry what are the Boolean expression? So there I can cover the operators. What are the operators which is supported in the Verilog? So that I change the plan. You know how to do gate level. 1 or 2 examples already we done. Let us go with the data flow, then we'll come into the gate level. Then we'll go to the behavioral model. Did you understand? So these are the knowledge is required to start with the level of abstractions. Okay. So we'll take a break for 5 minutes. After the break, we'll start with the assign statement. Assign statement means what? Data flow modeling technique. Basic building block for the data flow modeling technique. So we call that is nothing but continuous assignment statement. We call that is a continuous assignment statement. Why? What are the types of continuous assignment statements? So we'll begin after the break. We can take a break for 5 minutes. After the break, we'll start.
अपना किताब में कॉपी में लगाने का हो गया आपको, है कि ना? 5 रुपया में पैसे कॉपी में इतना खर्च देगा नहीं, 5 लोग कुछ खाने को भी हो गया ये भी घड़ी है, कलम है, पेन, लिप बोलते हैं नहीं बोल रहे हैं ये लगे ये भी 5 का नहीं क्या नहीं का ये कलम है नसीब में लगा जाएगा ना ना। अभी तो हम पहली बार ले लेते हैं, अभी हम पहली बार लाया हूँ, किसी में आता ट्राई है क्या, फिर से ट्राई करो। हाँ अच्छा 5 बजे देना है ना आपको, हम भूल गए यार।
Okay, let us start now. Start with the data flow modeling. Okay, what are the different level of abstractions we have? Me too. I'm going to copy this program here. So, what are the level of abstractions we have? What are the level of abstractions? Level of abstractions we have. One is switch level. Switch level. Then gate level. Then we have data flow. Then we have a behavioral model. Now we start with all the limitations. Okay, limitation of each module and which module is preferred, which level of abstraction we will prefer, we will discuss. So by this, now we understanding that what is the lexical convention and then port and port list connections. Right. Now let us start with what is the data flow module. Okay. What is the main building block for the data flow module is nothing but assign state using assign keyword. So we are going with the data flow module. Statement, whenever you are using assign statement, that assign statement we call it as a continuous assignment statement. Now let us take the same example here. This is a model design file I am writing for the full order. Using what keyword? Using assign keyword. So this will define this is my abilities. Okay, when you drop this assign statement, data is flowing through this technique. So this statements, this word statement, if I'm going to write, this is we call it as a continuous assignment statement. Continuous assignment statement. What is the rule of this continuous assignment statement? First, we'll understand what is the rule of this continuous assignment statement. A continuous assignment statement is the most basic statement in the what model? Data flow modeling, which is used to drive a value onto the net. Means this assign statement, this is now we call continuous assignment statement. Using this assignment statement, if I'm going to write the expressions or statements, this should be always a one. Continuous driven data type. What is meant by this continuous driven data type is? Which data type is a continuous driven data type? Net and wire are the continuous driven data type. So these statements usually in the data flow we call it as what? Continuous assignment statement. Why this we call it as a continuous assignment statement? So change in whether change in A or B or C, S is continuously changes. Correct? So is this is storing anywhere the value of S? Correct? It is continuously driven. It is computing each time it is continuously computing where A or B or C changes. It is not storing anything, so that this always in your assign statement LHS should be, there are rules to write the continuous assignment statement. What is the first rule is nothing but wherever you are using assign statement, this is a basic building block for the data flow modeling technique. The data flow modeling technique, the LHS side, this is I can write in my expression. This is my LHS side expression. Correct? This is nothing but what? RHS side. This RHS side can be declared as a rigid data type or wide data type. But this LHS